Draw complete diagrams of shear force and bending moment for a simply supported beam with a 30 kN load at the midspan and with a length of 12 meters. We remember that a beam supported by a pin at one end and a roller at the other end is called a simply supported beam or a simple beam. A pin support may have vertical and horizontal support reaction. The beam at the right has no applied horizontal loads, therefore HA equals 0. To solve this problem, we should start with finding the support reaction RA and RB. According to this problem, when we have a symmetrically loaded, simply supported beam, you can calculate the support reactions by dividing the total load by 2, because each of the support carries half the load. Next step is plotting diagrams of shear force and bending moment for a beam. Let's find out what the shear force and bending moment are. Cut the beam to the left of the point load and draw a free body diagram of the beam segment. In a free body diagram, forces must balance. Therefore, a downward force at the cut edge balances the support reaction RA. We call this shear force Q. The forces RA and Q are in balance, equal in value, opposite in sign. But our segment wants to spin clockwise about point A. To counteract this tendency to spin, a moment M develops within the beam to prevent this rotation. The moment M equals the shear force Q multiplied by distance from point A, C. Divide the beam into the segment so that the loading within each section is continuous. Analyze the part of the beam lying either to the left or to the right of the cutting plane, whichever is more convenient. Shear force is defined as the algebraic sum of all the vertical forces either to left hand or to the right hand side of the section. Bending moment is defined as the algebraic sum of the moments of all the forces either to the left or to the right of the section. To plot diagrams, we need to know sign conventions. Sign conventions for the shear force is: a clockwise shear will be taken as positive and an anticlockwise shear will be taken as negative. Shear force diagram has positive areas above the zero line and negative areas below the zero line. Sign convention for the bending moment is: a bending moment causing concavity upward will be taken as positive and will be called as sagging bending moment. A bending moment causing convexity upward will be taken as negative and will be called a hugging bending moment. To remember this rule easily, imagine that the bending moment makes the beam smile is positive, if not negative. A moment diagram has positive areas below the zero line and negative areas above the zero line. Let's start by plotting the shear force diagram. Draw a horizontal construction line indicating zero shear load. Cut off the beam on the right side of point A as close as possible to point A. Therefore, we can see shear force at the point A is equal to the support direction RA. Go up 15 kilonewtons at point A because RA is 15 kilonewtons upwards. Cut the beam as close as we can on the left side of section 1. In this case, as in the previous one, the shear force is equal to the support reaction RA because no additional loads on the beam until you get to the midspan. The shear force value remains at 15 kilonewtons. Draw a horizontal line to the right until you reach the point load F. Consider the second region. The applied load at the midspan is 30 kilonewtons downwards. Therefore, the shear load Q is 15 kilonewtons minus 30 kilonewtons is minus 15 kilonewtons. Draw a vertical line down, reaching a value minus 15 kilonewtons. There are no loads between the point load F and point B, so the shear load does not change. Draw a horizontal line to the right until you reach point B. Finish the shear diagram by shading the areas between your line and the horizontal zero shear line. Mark all significant points. Anywhere the shear line changes direction. Let's start plotting the bending moment diagram. Determine the bending moment M at every segment of the beam. If you remember, the moment about to point to the force acting on an object times the perpendicular distance from the force to the pivot point. Consider the first segment. We can see that support reaction RA makes the beam smile. Therefore, the bending moment is positive. Solving the equation, we get the bending moment at the beginning of the beam and at the end of the segment 1. The bending moment in the diagram is shown from the side of the stretched fibers. In our case, the stretched fibers are at the bottom of the beam. Write down the equilibrium equation of the second segment of the beam. There is a bending moment from the support reaction with sign plus and the bending moment from the force F with sign minus, because force F doesn't make the beam smile. Solving the equation and get the bending moment at the beginning of the segment 2 and at the end of the segment 2. Put this ordinate on the diagram and link it with the continuous line with the previous ordinate in first section. We have plotted the moment diagram. To summarize the results, shear force diagram is a graphical representation of the variation of shear force along the length of the beam. The ordinate of the shear force diagram at any section gives the value of the shear force at that section. Bending moment diagram is a graphical representation of the variation of bending moment along the length of the beam. The ordinate of the bending moment diagram at any section gives the value of bending moment at that section. After all, you must analyze and check your diagrams. Shear force diagram will be rectangle between point load. Bending moment diagram will be triangle between point load. The problem was solved correctly. Thank you for your attention. Happy practicing!